In Module 5, Lesson 1, we're going to look at the area of parallelograms through rectangle facts. We'll begin by reviewing some basic shapes. So first on the left, we have a right triangle. We know it's a right triangle because we have a right angle in the corner. Then we have what we traditionally call a parallelogram. And we have another triangle, which is an acute triangle. The shape below, which we traditionally know as a rectangle. And finally, a trapezoid. Now I'd like to point out before we move on further that there are actually two shapes in this group that are technically parallelograms. We most commonly identify this shape as a parallelogram, mainly because we were introduced to it when we were younger. But the definition of a parallelogram is that it is a quadrilateral, a four-sided figure, that has two sets of parallel lines. These two are parallel, and these two are parallel. Opposite sides are parallel. Since that is the only definition for parallelogram, rectangle fits that same description. Opposite sides are parallel, so it has two sets of parallel lines. But a rectangle is a specialized parallelogram because it also has four right angles. So our definitions in geometry are very, very important to the process. Continuing on, we're going to look at the area of a parallelogram. And we need to note that the figures are not drawn to scale, so you can't use a measure to answer these questions. In exercise 1, we have a parallelogram. Its base is 6 and its height is 4 centimeters. The height is extremely important when you're looking for area because you don't multiply side times side. You multiply the base times the height, where the height is a line drawn from the upper part of the figure to the base at a 90-degree angle. So in these parallelograms, since our sides are not at 90-degree angles, we don't multiply base times the side. Once we know that, then the area of this parallelogram would be 6 times 4, or 24 square centimeters. And in area, we refer to the units as square units because we are talking about what will fill the inside of this space, and we can only fill it with little square pieces similar to this marking for the right triangle, little square pieces that fill the space. In the second quadrilateral, we have a base of 25 and a height of 8. So the area is 25 times 8, or 200 square centimeters. Please notice when we find the area of a figure, it is not the number that is squared, it is the units that are marked as squared. And then in our third figure, we have a base of 12 and a height of 7, which is 84 square feet. Need to fix this unit here. There we go. One last time to review. You are multiplying the base times the height, where the base is the side that is perpendicular to the height. So when you see the height drawn, wherever it is connecting, that side is considered your base. So we have base times the height, which again is a line that is drawn perpendicular to the base. And then our units are in whatever unit we're given in the picture squared. So in number 2, they're asking us to draw and label the height of each parallelogram and use the correct mathematical tool to measure the base and the height in inches, and then calculate the area of each parallelogram. So there's going to be some measurement on your part, but just so that we are sure about how to draw the height, I am going to show you how I would draw the height in these figures, and then you'll have something to base your measurements on. So in viewing figures A and B, I drew the height with a green pen so that you could see that the height needs to be perpendicular to the base. And so when you do your measurements, you would measure the base and then the height, which was perpendicular to the base. Some common ways that you could make this line perpendicular to the base would be to use the edge, the corner edge of a sheet of paper. The corner edge of a sheet of paper is always 90 degrees. So if you laid that paper, one side of the paper, along the base, with the rest of the paper facing up, you would be able to see exactly where that line needs to hit the base, and then extend your line with a ruler. Same thing here. Now in figure C, you'll notice that that parallelogram is tilted quite a bit. And in order for us to draw a line that is perpendicular to the base, we actually need to extend the base to be able to find that perpendicular spot. And that as well is perfectly fine. If we were to take this parallelogram and cut it into slices and then try to move the slices over to stack them, it would still have the same height. So just so you see the picture of that. In many test questions, what you would see is exactly this, only these green lines would be dotted lines to make it clear that they are not part of the figure. They are just an extension in order for us to get the correct measurement. The correct measurement always has to be perpendicular to the base, even if you have to extend the base in order to get that perpendicular spot. So now in question number 3, they're giving us the area of the parallelogram and the height. They're asking us to write an equation that relates the height, the base, and the area of the parallelogram, and then solve the equation. So as a review, the area of a parallelogram is base times height. And we'll take that formula now and substitute the information that we have so that we can solve for the information we don't have. They've told us the area is 35/42, and the height is 1/7. So base times the height, which is 1/7. And I'm putting that in parentheses because while I'm completing this, it is easier to show my multiplication without a symbol. And in order for me to show that, I have to have my number in parentheses and then my variable outside. Now, if you remember solving equations, what you should remember about this is in order to solve, you've got to do the opposite operation that's being done. So what we have here is b times 1/7. So in order to solve it, we're going to divide by 1/7 on both sides. So then if we are dividing 35/40 seconds by 1/7, remember to divide fractions, you need to flip the second fraction and multiply. That gave us 245/40 seconds. I converted it back to a mixed number and then simplified the fraction part by dividing by 7 on both the numerator and denominator, and got 5 5/6 centimeters. Remember, the formula to calculate the area of a parallelogram is area equals base times height, where B represents the base and H represents the height of the parallelogram, and the height of the parallelogram must be perpendicular to the base.